All right, let's go. Number 10. Unknown interstellar objects. For centuries, astronomers operated under a comfortable, unspoken assumption. The threats to our planet existed entirely within our own solar neighborhood. We tracked the comets of the Oort cloud, we mapped the asteroids of the Kuiper belt, and we calculated the orbital mechanics of our local debris. We believed we had a handle on the cosmic clockwork. That illusion of safety was permanently shattered on October 19, 2017, when the Pan-STARRS 1 telescope in Hawaii detected an object moving at speeds that defied the gravitational laws of our solar system. Traveling at an astonishing 196,000 miles per hour, the object was on a hyperbolic trajectory. It was not bound by the sun's gravity. It had come from the deep interstellar void, passing through our system like a bullet through a paper target, and was already on its way back out into the dark. We named it Oumuamua. What makes unknown interstellar objects so terrifying to the scientific community is our absolute inability to see them coming. Oumuamua was only detected after it had already passed its closest approach to the sunday. If its trajectory had been angled just a fraction of a degree differently, if it had been on a collision course with Earth, we would have had virtually zero warning. Standard planetary defense protocols assume we will have decades, or at least years, to spot an incoming asteroid, calculate its orbit, and formulate a deflection mission. Interstellar objects strip away that luxury of time. They emerge from the blackness of space at relativistic speeds, unlit by any host star, remaining completely invisible until they cross the threshold of our own sun's light. The kinetic energy carried by an object traveling at interstellar speeds is almost incomprehensible. An asteroid from our own solar system strikes Earth at roughly 40,000 miles per hour. An interstellar interloper could strike at speeds exceeding 200,000 miles per hour. At those velocities, even a relatively small object would carry the destructive yield of the global nuclear arsenal multiplied 1,000 times over. The impact wouldn't just cause a mass extinction. It could physically shatter the Earth's crust, boil the oceans instantly, and strip away portions of the atmosphere. Furthermore, statistically speaking, Oumuamua and the subsequently discovered interstellar comet Borisov are not anomalies. Astrophysicists now calculate that there are trillions of these rogue objects drifting through the Milky Way, ejected from their home star systems by gravitational perturbations during planetary formation. Our solar system is constantly moving through a cosmic shooting gallery, sweeping up these invisible bullets as it orbits the galactic center. We are flying blind through a dark forest filled with dead, frozen rocks, any one of which could end human history in an afternoon. There is no defense. There is no early warning system. There is only the unsettling mathematical probability that sooner or later, one of these interstellar wanderers will hit the target. Number 9. Cosmic ray storms. When we think of deadly radiation from space, we naturally look to our sunday. Solar flares and coronal mass ejections present a genuine threat to our modern electrical grid. But in the grand hierarchy of cosmic violence, our sun is a remarkably gentle, stable star. The true terror lies beyond our solar system, in the form of galactic cosmic rays, GCRs. These are not rays in the traditional sense of light or radiation. They are actual subatomic particles, protons and atomic nuclei, accelerated to 99.99% the speed of light by the most violent events in the universe. They are forged in the crushing death throes of exploding supernovae, fired from the magnetic poles of rapidly spinning pulsars and launched across millions of light years by the supermassive black holes at the centers of active galaxies. Earth's magnetic field and atmosphere act as a robust shield against the low-energy solar wind, but they are terrifyingly porous when it comes to high-energy galactic cosmic rays. When a high-energy cosmic ray strikes the upper atmosphere, it shatters the nucleus of an atmospheric gas atom, creating a cascade of secondary radiation, a shower of muons, electrons, and secondary neutrons that rain down upon the surface. On a normal day, this background radiation is a minor nuisance, a tiny contributor to the natural radiation we absorb. But scientists fear the arrival of a cosmic ray storm, a dense, focused wave of high-energy particles sweeping through our local region of space. If a nearby star were to go supernova, or if our solar system were to pass through a particularly dense cloud of interstellar plasma, magnetized by ancient stellar explosions, the influx of cosmic rays would be catastrophic. The initial barrage wouldn't fry the planet in a flash of heat. The destruction would be far more insidious. A massive increase in cosmic rays would systematically destroy the Earth's ozone layer. High-energy particles would break apart nitrogen molecules in the atmosphere, which would then bond with oxygen to form nitrogen oxides, aggressively eating away the ozone shield. Within months, the planet's surface would be bathed in lethal levels of ultraviolet radiation from our own sunday. The food chain would collapse from the bottom up as phytoplankton, the foundation of oceanic life, were sterilized. For technological civilization, the effects would be equally devastating. Cosmic rays carry enough kinetic energy to flip the physical bits in computer memory, a phenomenon known as a single event upset. In a cosmic ray storm, the silicon infrastructure that governs the modern world, from satellite navigation and global banking to the microprocessors controlling nuclear power plants and water purification facilities, would suffer simultaneous, catastrophic hardware failures. We would be plunged into a dark age, not by a bomb or a virus, but by invisible, subatomic shrapnel fired from a dead star 1,000 light-years away. Space is inherently hostile to biology, and the only thing keeping us alive is a fragile atmospheric membrane that could be shredded by a cosmic storm at any moment. Number 8. Brown dwarf wanderers. In the classification of celestial bodies, there exists a twilight zone between the largest planets and the smallest stars. These objects are known as brown dwarfs, and they represent one of the most insidious hidden threats in the galaxy. When a cloud of interstellar gas collapses to form a star, it must accumulate enough mass to ignite the sustained nuclear fusion of hydrogen in its core. Brown dwarfs are the cosmic failures of this process. They gather between 13 and 80 times the mass of Jupiter, heavy enough to briefly ignite the fusion of heavy hydrogen or deuterium, but not massive enough to sustain the true, blinding fire of a main sequence star. Because they cannot sustain hydrogen fusion, brown dwarfs do not shine. They emit a faint, dull glow of residual heat in the infrared spectrum, cooling steadily over billions of years until they become little more than incredibly dense, freezing spheres of gas drifting in absolute darkness. What terrifies scientists is their sheer number and their complete invisibility to standard optical telescopes. Current astrophysical models suggest there could be up to 100 billion brown dwarfs wandering aimlessly through the Milky Way, completely untethered to any planetary system. They are the galaxy's silent, massive ghosts. The existential threat of a rogue brown dwarf does not come from a direct collision. Space is unimaginably vast, and the odds of a direct planetary strike are infinitesimally small. The danger lies in gravity. The outer edge of our solar system is encased in the Oort cloud, a spherical shell containing trillions of dormant comets and icy bodies weakly bound by the sun's gravity. If a rogue brown dwarf were to drift silently through the edges of the Oort cloud, its massive gravitational footprint would violently disrupt this delicate equilibrium. We would have absolutely no visual warning of its approach. Our optical telescopes would see nothing but black space. By the time our infrared surveys detected the faint heat signature of the approaching mass, the gravitational damage would already be done. The Wanderer's passage would dislodge millions, perhaps billions, of comets from their stable orbits, sending them plummeting inward toward the inner solar system. We would not face a single extinction-level asteroid, but a relentless, centuries-long bombardment of cometary impacts. The night sky would be filled with the glowing tails of incoming doom, a continuous meteor shower raining fire upon the Earth. The brown dwarf itself would drift back into the cosmic dark, completely indifferent to the planetary apocalypse it had casually triggered simply by passing through the neighborhood. Number 7. Failed stars. While rogue brown dwarfs represent a gravitational threat to our solar system, examining the actual environments of these failed stars reveals a localized nightmare that challenges our understanding of atmospheric physics. For decades, we viewed celestial bodies through a binary lens. They were either cold, dead planets or burning, life-giving stars. The discovery of ultra-cool dwarfs and high-mass brown dwarfs forced astronomers to confront a terrifying middle ground. Worlds that possess the crushing gravity of a star, but the chaotic, weather-driven atmospheres of a gas giant. Take Lumen 16, a binary brown dwarf system located just 6.5 light-years away from Earth. Through complex spectrographic analysis and Doppler imaging, scientists have mapped the weather patterns on these dark, heavy worlds, and the results are staggeringly hostile. Because they do not generate enough internal heat to completely vaporize their elements, but are still far hotter than any planet, their atmospheres exist in a bizarre, violent state of phase transition. The atmospheric temperatures hover around 2,000 degrees Fahrenheit. At these temperatures, the clouds are not made of water or ammonia. They are composed of vaporized silicates and liquid metals. On a brown dwarf, it literally rains molten iron and liquid glass. The atmosphere is a churning, chaotic cauldron of extreme convection. Heat from the slowly cooling core violently clashes with the freezing vacuum of space, driving supersonic winds that whip these metallic storms across the surface at thousands of miles per hour. Because these objects are so incredibly dense, their rotation rates are often ferociously fast, some spinning completely on their axes in just a few hours. This rapid rotation generates magnetic fields thousands of times more powerful than Jupiter's, creating localized magnetic storms and auroras that crackle with millions of volts of electricity arcing through clouds of molten rock. The terror of the failed star is philosophical as well as physical. It demonstrates that the universe is not neatly organized into habitable zones and sterile stars. The cosmos actively produces hellscapes as a standard byproduct of its mechanical processes. If a human observer were somehow dropped into the atmosphere of a brown dwarf, the sequence of their destruction would be difficult to chronologize. They would be simultaneously crushed by gravity hundreds of times stronger than Earth's, incinerated by 2,000-degree ambient heat, shredded by supersonic winds carrying droplets of liquid iron, and irradiated by massive magnetic outbursts. These worlds are cosmic monuments to absolute hostility, proving that nature's default state is one of brutal, unrelenting extremity. Number 6. Dark galaxies. In the 1970s, astronomer Vera Rubin discovered that galaxies were spinning too fast. According to the laws of Newtonian physics, the visible matter in a galaxy, the stars, the gas, the dust, did not possess nearly enough mass to generate the gravity required to hold the spinning structure together. The outer edges of spiral galaxies should have been flinging stars into the intergalactic void, yet they held tight. The only mathematical explanation was that the visible universe was surrounded and outweighed by an invisible scaffolding. We called this invisible mass dark matter. It interacts with ordinary matter only through gravity, refusing to emit, reflect, or absorb any form of light. For decades, we assumed dark matter was just the hidden skeleton upon which normal, star-filled galaxies were built. But in 2016, astronomers studying the Coma Cluster discovered Dragonfly 44. To standard telescopes, it appeared as little more than a faint, barely perceptible smudge of light. But when scientists measured the velocity of the few stars it possessed, the mathematics revealed something chilling. Dragonfly 44 has roughly the same mass as our entire Milky Way galaxy, yet it emits only 1% of the light. It is a galaxy composed of 99.99% dark matter. It is a massive galactic-scale ghost. The existence of dark galaxies completely upends our understanding of cosmic geography. It means that the universe is populated by enormous, galaxy-sized gravity wells that are completely invisible to our eyes and our instruments. We navigate the cosmos by looking for the light of stars, assuming that where there is light, there is mass. Dark galaxies prove this assumption fatally wrong. The universe's largest structures are hiding in the dark, exerting tremendous gravitational influence while remaining entirely undetectable to the electromagnetic spectrum. The scientific fear lies in the unpredictable dynamics of these massive dark structures. While galaxies are separated by millions of light years, they do collide and merge over cosmic time. If a dark galaxy or a massive, dense clump of dark matter were to intersect with the Milky Way, we would see absolutely nothing approaching. But the gravitational devastation would be catastrophic. The invisible mass would warp the galactic disk, displacing billions of stars, throwing solar systems into chaotic new orbits, and potentially stripping entire spiral arms away from the galactic center. Earth could be torn from its comfortable orbit around the sun, or the sun could be flung out of the galaxy entirely, doomed to drift through the freezing intergalactic void. We are living in a universe dominated by an invisible substance that outweighs us 5-1, and we are utterly blind to its movements. Number 5. Black hole accretion disks. Black holes are often conceptually misunderstood as simple cosmic vacuums, dark voids that quietly swallow everything that crosses their event horizon. But scientists know that the true terror of a black hole lies not in the darkness of the singularity, but in the blinding, violent halo of matter that surrounds it. This is the accretion disk, and it represents the most efficient, destructive energy conversion mechanism in the known universe. When a black hole feeds on a nearby star or a cloud of interstellar gas, the matter does not simply fall straight in. Driven by the conservation of angular momentum, the material spirals inward, forming a flattened disk around the black hole's equator. As the matter falls deeper into the black hole's gravitational well, it is accelerated to a significant fraction of the speed of light. At these relativistic speeds, the friction between the particles becomes unimaginable. The gas and dust are superheated to millions of degrees, transforming into a glowing, churning plasma. The inner edge of the disk, hovering just outside the point of no return, is subjected to gravitational shearing forces so intense that they strip electrons from their atomic nuclei. The disk becomes a raging inferno of subatomic violence, generating magnetic fields that twist and snap with catastrophic force. The energy released by an accretion disk is so profound that it outshines everything else in the cosmos. When supermassive black holes at the centers of distant galaxies feed aggressively, their accretion disks become quasars, objects that can emit thousands of times more light than the entire Milky Way galaxy combined, despite being no larger than our solar system. The radiation pouring off an active accretion disk includes lethal doses of hard X-rays and gamma rays. If our sun were replaced by an actively feeding black hole of the exact same mass, the Earth would not be sucked in, as the gravitational pull at this distance would remain the same. But the radiation emitted by the accretion disk of the infalling solar wind would sterilize the surface of our planet in a matter of hours. The accretion disk strips away the romanticized mystery of the black hole and replaces it with visceral, mechanical horror. Before matter can ever reach the silent mystery of the event horizon, it must first survive the disk. It is a cosmic meat grinder. If you were falling toward a feeding black hole, you would never live to experience the theoretical weirdness of spaghettification or time dilation at the event horizon. Long before you cross that threshold, the sheer friction and hard radiation of the accretion disk would vaporize your body, breaking you down into a stream of superheated plasma, feeding your atomic structure into the brightest, most violent bonfire in the universe. Number 4. Gravitational wave catastrophes. In 1916, Albert Einstein published his general theory of relativity, proposing that space and time were not a static backdrop to the universe, but a flexible, physical fabric. He theorized that the most violent accelerations of mass in the cosmos would create ripples in this fabric, radiating outward at the speed of light. For exactly 100 years, gravitational waves remained a purely theoretical concept until 2015, when the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected a signal. It was the faint, momentary distortion of space caused by the collision of two black holes 1.3 billion light-years away. The detection was a triumph of physics, but it also revealed the terrifying scale of cosmic violence. In the final fraction of a second before those two black holes merged, they converted 3 times the mass of our sun into pure gravitational energy. For that briefest of moments, the collision generated more power than all the light from all the stars in the entire observable universe combined. But this energy was not released as heat or light. It was released as a violent physical distortion of reality itself. The wave propagated across the cosmos, stretching and squeezing the very geometry of space. By the time it reached Earth 1 billion years later, the distortion was so infinitesimally small that it moved LIGO's mirrors by a distance thousands of times smaller than a proton. But what scientists fear is the prospect of a localized gravitational wave event. The universe is littered with binary systems of dead stars, neutron stars, and black holes locked in decaying orbits, inevitably spiraling toward violent mergers. If a mass conversion event of that magnitude were to occur within our own galactic neighborhood, just a few dozen light-years away, the gravitational wave would not be a microscopic curiosity. It would be a catastrophic macro-scale event. As the wave passed through our solar system, it would physically stretch and compress the space that the Earth occupies. The planet itself would be rapidly warped, stretched into an ellipsoid, and then compressed back, repeatedly, as the wave rippled through. Even a minor spatial distortion would shatter the Earth's tectonic plates, triggering simultaneous catastrophic global earthquakes and hypervolcanism that would crack the planet's crust. The oceans would be thrown into chaotic, continent-drowning tsunamis. The orbits of the planets could be permanently destabilized. There is no bunker deep enough, no shielding thick enough to protect against a gravitational wave. You cannot hide from a threat that is woven into the very fabric of existence. If the geometry of the space you occupy distorts, you distort with it. Number 3. Unmapped cosmic structures. Humanity has mapped the surface of the Earth, charted the orbits of the planets, and meticulously cataloged the stars in our local galactic neighborhood. But when astronomers zoom out to observe the macrostructure of the universe, they find anomalies that defy our understanding of cosmic physics. The universe is not a uniform, evenly distributed soup of galaxies. It is organized into a vast, honeycomb-like cosmic web of filaments and nodes, separated by unimaginably large voids. And within this web, there are structures exerting gravitational pulls that we cannot fully explain or even clearly see. The most famous of these is the Great Attractor. In the 1970s, astronomers measuring the cosmic microwave background radiation discovered that our entire Milky Way galaxy, along with the Andromeda Galaxy and dozens of others in our local group, are hurtling through space at a staggering 1.3 million miles per hour. We are not just drifting, we are falling. We are being pulled toward a specific region of space, located about 150 million light years away. The terrifying part is that the Great Attractor lies directly behind the zone of avoidance, the dense, dusty disk of our own Milky Way galaxy, which obscures our view of whatever is pulling us. Recent infrared and X-ray observations have peered through the dust, revealing massive clusters of galaxies like the Norma Cluster and the Shapley Supercluster, containing the mass of tens of thousands of Milky Ways. But even these colossal structures do not fully account for the gravitational force dragging our entire region of the universe. There is mass missing from our calculations. We are caught in a cosmic riptide, being pulled relentlessly toward an unimaginably dense concentration of matter whose true nature remains partially hidden in the dark. Equally terrifying are the voids. The Boötes Void, discovered in 1981, is a spherical region of space, measuring roughly 330 million light-years in diameter. Based on the average density of the universe, a region that size should contain over 10,000 galaxies. The Boötes Void contains fewer than 60. It is a staggering expanse of almost perfect nothingness. If the Milky Way had been placed in the center of the Boötes Void, we would not have known that other galaxies existed until the invention of deep space telescopes in the 1960s. These anomalies, the unseen masses pulling us in the dark, and the colossal, inexplicable voids remind scientists of our profound vulnerability. The architecture of the cosmos operates on a scale of violence and mass that renders humanity a mathematical rounding error, drifting through a universe whose structural blueprints we still do not understand. Number 2, unknown forms of matter. We build our lives, our sciences, and our philosophies around the matter we can interact with. The protons, neutrons, and electrons that make up the Earth, our bodies, and the stars represent the entirety of the physical world we know. But theoretical physics suggests that the universe may harbor exotic forms of matter that operate under completely different, fundamentally lethal rules. Among the most feared theoretical concepts in astrophysics is strange matter, specifically in the form of strangelets. In the crushing cores of neutron stars, the pressure is so intense that protons and neutrons dissolve into a soup of their constituent fundamental particles, called quarks. Usually, matter is made of up and down quarks, but under this extreme pressure, they can transform into strange quarks, creating a hyperdense, perfectly stable new phase of matter. If two neutron stars collide, they could eject microscopic fragments of this material into the cosmos. These fragments are strangelets. They are smaller than an atom, denser than the core of the Sun, and, according to the strange matter hypothesis, perfectly stable outside the intense pressure that forged them. The existential terror of a strangelet is not its mass, but its absolute infectiousness. According to theoretical models, strange matter is the most stable state of matter in the universe. If a strangelet were to come into contact with ordinary matter, say, the atmosphere of the Earth, or the rock of its crust, it would not just pass through. It would violently reconfigure the ordinary matter, converting its up and down quarks into strange quarks. The newly converted strange matter would then convert the matter next to it, triggering an unstoppable runaway chain reaction. If a strangelet the size of a single grain of dust were to strike the Earth, the conversion process would take only a matter of seconds. The entire planet, the oceans, the mountains, the atmosphere, and every living biological organism would be instantly catalyzed and compressed. The Earth would be reduced to a hyperdense sphere of strange matter, barely 300 feet across, radiating the immense thermal energy released by the conversion process. There would be no explosion, no warning, and no defense. It would be a quiet, instantaneous deletion of our physical reality, rewritten by an exotic subatomic law. While the existence of strangelets remains theoretical, the math allows for them, sitting quietly in the equations of quantum chromodynamics, a reminder that the fundamental laws of physics could, theoretically, rewrite our existence on a subatomic whim. Number 1. The universe's event horizon. The ultimate fear held by cosmologists is not a sudden, violent apocalypse. It is the slow, silent, mathematical certainty of absolute cosmic isolation. In 1998, astronomers attempting to measure the deceleration of the universe's expansion discovered the exact opposite. The expansion of the cosmos is accelerating, driven by a mysterious, repulsive force we call dark energy. Dark energy operates as a property of space itself. As space expands, more dark energy is created, which drives the expansion even faster. It is a runaway cosmological train, and it dictates a deeply tragic final act for the universe. Because the expansion of space is accelerating, the distant galaxies we see in our telescopes are receding from us faster and faster. The rate of expansion is measured by the Hubble constant, and it leads to an inevitable, chilling threshold called the cosmological horizon. Eventually, the space between our local galactic group and the rest of the universe will be expanding faster than the speed of light. This does not violate Einstein's laws, as it is the space itself expanding, not the objects moving through it. But the result is the same. The light from those distant galaxies will no longer be able to cross the expanding gulf to reach our eyes. Over the next 100 billion years, the observable universe will begin to empty out. The billions of galaxies that currently fill our deep field telescope images will slowly redshift into the infrared, then into radio waves, and eventually fade into complete blackness. They will cross the cosmic event horizon, slipping beyond our ability to ever see, contact, or reach them. The Milky Way will merge with Andromeda to form a single, massive, elliptical galaxy. But beyond our immediate local group, there will be nothing. An observer standing on Earth 1 trillion years from now will look up at the night sky and see only the stars of our own galaxy, surrounded by an infinite, pitch-black void. Future astronomers will have no evidence of the cosmic microwave background radiation. They will have no visual proof of the Big Bang, no evidence that other galaxies ever existed, and no way to know that the universe is expanding. The physical evidence of cosmic history is actively being erased by dark energy. They will naturally and logically deduce that their solitary galaxy is the entire universe, floating alone in an endless dark room. The greatest terror of deep space is not that it will kill us, but that it will eventually trap us in an eternal quarantine, erasing the records of existence until the last stars burn out, leaving nothing but cold, expanding nothingness.